Hello students, welcome to the computer science department. Let us begin your third chapter, that is data representation. Okay, you all know what is data. We have studied it in the first chapter, right? Any information that we provide to the computer is the raw, the unprocessed information is called as data, correct? But when it is processed, you all know that the computer can understand only the binary digits, isn't it? Whatever the data we give has to be converted to what? It has to be converted to binary digits, right? What is the short form of this binary digits? Take two words or two letters from the first word and last two letters from the second word. It becomes bits, right? So bits, what are bits? It is nothing but the binary digit, sequence of binary digits. Now, when we hear this binary digit, we do not know what is binary digit. Okay. In maths, we understand what is digit. What is digit? Any single number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay. Any single number is a digit. Correct? That we know. But we know it in the decimal number system. Correct? What we use in maths today is decimal number system. That means 10 numbers, 0 to 9. 10 digits are there in decimal number system, correct? But here your computer uses a different number system, and that is binary number system, correct? So with this we come to know that there are different types of number systems, isn't it? So when there are many number system types, we have to understand how to convert from one number system to another number system, and that is the basis of this chapter. I hope the introduction is clear to every one of you. So let us now see the types of number system, correct? Number system, as we know, is divided mainly into two types, that is non-positional number system, first one, and second one, positional number system. Okay, now what is position? You all have studied it in your primary units, tens, hundreds, thousands. These are the positions, correct? Whatever we use with the weightage or with the position, whatever we represent with the position is the positional number system. But earlier to this is what we use today, but earlier to this, non-positional number system was in existence. You have, I think, studied this. This is like, see here, I used I, correct? What is this? When I say I, you say it as 1. When I say I, you say it as 2. I, when you use, it's 3. But for 4, what we use? V, correct? So, the non-positional number system is like, you do not have the number with its position. You do not weigh the number with its position. You give some random alphabet to a digit or to a number. Which type of number system is this? Can you guess? I think some of you would have guessed it. It is called as Roman number system. Correct? Roman number system. What happens in Roman number system? You do not have any positions. You just say I for 1, correct? V for 5, right? X for 10, right? L for 50, C for 100, M for 1000, and so on. D is there, 500. So in this way, we do not have any specific position given to the number, we have certain random alphabets given. Okay, now that is the Roman number system and we call it as non-positional number system. Is that clear to everyone? Yes. Now let us study the second type, that is positional number system. Okay. Now it has got 4 types in it. The decimal number system, which we normally use in maths today, most widely used one. The binary number system, which is understood by the computers or any digital device. Understanding? The digital device, when we say, it works on this binary number system. That we have to keep in mind. Some other 2 number systems are there, octal and hexadecimal number systems. Okay. Now on what basis do we divide these number systems is the question. Okay. When I said decimal, tell me which are the digits that come in decimal. You say 0 to 9, correct? 0 to 9. How many digits are there in 0 to 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 digits. Am I right? 10 digits are there in decimal number system. Okay. When I say binary, I have only 2 digits, 0 and 1. 0 and 1. So whatever number I say, I have to say it only within zeros and ones. It's like in decimal, when I say 0, 1, 2, 3, 4, 5, 7, 6, 7, 8, 9, then what? Then 10. 10 means it is the combination of the first 2 digits. Then 11, then 12. Means only these are the digits, 0 to 9, main digits. With this, you form the numbers to lakhs and crores. But these are the basic digits, correct? Like that, in binary, only 2 digits are there, 0 and 1. Then whatever comes has to come in 0 and 1 only. That we have to study in detail. Okay, fine. Now that means how many digits are there in binary number system? 2 digits, correct? 2 digits. Then in octal we use the digits from 0 to 7. Okay, oct is the word for what? 8, correct? So 0 to 7, these digits are used and hence it has totally 8 number of digits in it. Okay, and hexadecimal we use from 0 to 15. 0 to 15. So totally there are 16 digits. Decimal is 10. Hexa is 6. 10 plus 6, 16 total digits are there in hexadecimal number system. Okay, try to understand this first. Now, what all are these 10, 2, 8, 16? What are these? These are the total number of digits in that specific number system, isn't it? And that is called as base, or there is another name, that is radix. Okay, base or radix. Now what is base or radix? How do you define it? See, pause the video and write it. Okay, the base is nothing but, or the radix is nothing but the total number of digits present in a specific number system. Okay, that is base. So when I say what is the base for decimal, you have to say it as 10. What is the base for binary? 2. What is the base for octal? 8. What is the base for hexadecimal? 60. This is what we have to say. Understanding? Okay. Okay. Now let us study the decimal number system first, because it is most widely used one, isn't it? And we all know how this is worked. Okay. So for decimal number system, we know that we have 10 as the base, correct? 10 is the base of decimal number system. Now, when the 10 is our base, if I have a number like this, okay, 512.46, which type of decimal, which type of number system it is? It is decimal number system. Okay, when I write it write the 10 as the subscript for this number. Okay, this means that it is the base of this number. Understanding? So 512.46 is the decimal number now. What does this mean? This means 500, correct? 5 comes in hundreds. Then tens will have 1. Unit place will have 2. Right? Now after the decimal, whatever comes is first 1/10. Correct? 1/10 of the number. Then whatever comes is 100. And so on. 1000, 1/10,000. Like this it goes. Units, tens, hundreds, thousands, 10,000s. When you go to the left, when you go to the right, that is after the decimal, you have to go on reducing. Correct? So, what does this mean? 5 into 100. Correct? 1 into 10. 2 into 1. Because it is units. Correct? Then what? 4 into 1 by 10. What it is? 4 into 1 by 10. 1/10. And 6 into 1 by 100. What happens when you add these all things? What happens? See, 5 into 100, 500. Correct? 1 into 10, 10. So 500 plus 10 plus 2 plus 4 into 1 by 10 is 0.4. Correct? 4 into 1 by 10 is 0.4 plus 6 into 1 by 100 is 0.06. Am I right? Okay. When you add this, 500 plus 10, 510 plus 2, 512 plus 4, 512.4 plus 0.06, 512.46. Okay. So, when any decimal number is given, you can represent it in this way with hundreds, tens, units and so on as the positions. This number has got its position in hundreds. This number has got its position in tens. So, we say this decimal number system as the positional number system. Are you understanding this? Fine. Now, where this 10 comes into picture, that we have to understand. Okay, where this 10 comes into picture. So, this whole system, I'll write it in another way. Okay? Fine. This is, I can write it as 5 into 10 raised to what? 100 is there. Correct? 100 is there. 10 raised to what is 100? 10 square is 100. Correct? 10 square is 100. Here 1 into 10 means 10 raised to 1 it is 10 raised to 1 is 10. So 10 place will have 1 as the integer. And here 2 into 10 raised to 0. Anything raised to 0, the basic maths, any number x raised to 0 is always what? 1. Okay, we know this. So 2 into 10 raised to 0, 10 raised to 0 means 1, 2 into 1 means 2, right? And so on if you go, 2, 1, 0, then what? When you go on the number line, okay, here you are increasing it, 0, 1, 2, 3 like this. When you go that side, you will have 4 into 10 raised to minus 1. See, this is reducing, 2, 1, 0, then what? Minus 1, correct? 6 into 10 raised to minus 2, isn't it? So whatever I was writing before, that is 5 into 100, 1 into 10 can be now written as 5 into 10 raised to 2, 1 into 10 raised to 1. So this 10 can be considered as the base. Now you understand why it is called as base. Whenever I write a number, for example 6 raised to 2, whenever I write an exponential number, 6 raised to 2. Now this 2 is called as power, correct, or exponent. This 6 is called as base, right? So here what forms the base? 10 forms the base, and hence 10 10 is the base of this decimal number system. This is the concept. Are you understanding it? 10, see, when you go on to the left side, from 0 it starts and it goes on increasing. Okay, unit place must have 0 as the power. Okay, because you have to get 1 in there. So to get 1, anything raised to 0 will be 1, and hence to 10 raised to 0. So as you go on to the left, 0, 1, 2, 3, it goes on. When you go to the right, minus 1, minus 2, minus 3, it goes on. Did you understand that? Now, just as an example, you try it, take it as an assignment. If you are given the number as 6536.698, okay, this is the number given, 6536.698. Let me tell this one, then give another as an assignment. Okay, how many places you need? Units, tens, hundreds, thousands also I need. Correct? Here 1/10, 100, 1000 also I need. Right? So U, P, H, then thousands. Okay, here 1000. Right? I can write this as 6536.698. Okay, now represent this in the decimal number system with 10 as the base. Can you people try it out? Those who can try, pause the video and try, and then see the video later. Okay, so this is 1000. Fine. First, just write the base. We will do it easier. First, just write the base. 6 into 10, 5 into 10, 3 into 10, 6 into 10, then again 6 into 10, okay, point here. Then 9 into 10, then 8 into 10. Okay, this is what we have. What are the exponents written now? Units place will always have 0 as the exponent. This is fixed. As you move to the left side, the exponent has to increase. 0, 1, 2, 3. Am I right? As you move to the right side, the exponent has to decrease. So from 0 it will be minus 1, minus 2, minus 3. Correct? So when you say this, 6 into 10 raised to 3. 10 raised to 3 is what? 10 square is 100. 10 raised to 3 means 10 into 10 into 10. 10 tens are 100. 100 tens are 1000. So 10 raised to 3 is 1000. 6 into 1000 means 6000. Correct? 6000. Then 5 into 10 raised to 2. 10 raised to 2 is 100. 5 into 10 raised to 2 means 500. Correct? 3 into 10 raised to 1. 10 raised to 1 is 10. 3 into 10 raised to 1, that is 3 into 10 is 30. Plus 10 raised to 0 is 1. 6 into 1 is 6. Correct? 6. Then 6 into 10 raised to minus 1. Yes. Now what is 10 raised to minus 1? Please remember your maths basics. Try to recall. 10 raised to minus 1 is nothing but 1 by 10. You have to understand this. You know it already. Okay? 1 by 10 means 10 raised to minus 1. When I say 10 raised to minus 2, it is 1 by 100. You all know this. Okay? This is simple maths. So 6 into 10 raised to minus 1 means 6 into 1 by 10. That means 6 by 10. 6 by 10 is 0.6. Correct? Then 9 into 10 raised to minus 2. 10 raised to minus 2 is what? 1 by 100. 9 by 100. 9 by 100 is 0.09. Okay. 8 into 10 raised to minus 3. 10 raised to minus 3 is 1 by 1000. That means 8 by 1000. 8 by 1000 is 0.008. Am I right? Okay. So when you add these, 6000 plus 500 is 6500. 6500 plus 30 is 6530. Plus 6 is 6536.6. plus 0.09 plus 0.008 is 698. You can add this easily. Okay. So you get this number with the base as what? 10, and you can represent it like this. Understanding? So now let me give some numbers. You please try them and try to represent it with the positions. Okay. So your number is 11,987.543. Okay, this is one number. What is the base of this? 10 is the base. That means you have to represent it like this. Correct? Another number, 8,542. Say 219. Okay, this also 10 is the base. Then 1993.2504. This also 10 is the base. Will you try this at home? So in this video we have just learnt about the decimal number system. In the coming video we will be handling with the binary, octal and hexadecimal number system. Okay, thank you.